Okay, guys, welcome. Today we're going to talk about dividing radicals. All right. So the last thing that we talked about was multiplying radical expressions. So now we're going to talk about how we can apply that to now dividing radicals. All right. So I just want to call your attention again to some important rules that we'll need along the way. So of course, the first one again is our property that allows us to write anything in radical form as an exponent. We'll also need again the fact that you can split up radicals, by just taking the product of the individual radicals. And then the other thing that we'll, of course, need now for division is that we'll need to keep in mind that if you divide two terms of the same base, you subtract their exponents. All right. So now the way that we actually go about dividing these things utilizes a process that's called rationalizing the denominator. And essentially what that means is that we need to do this process here. So to rationalize the denominator, basically what you're doing is you're multiplying the top and bottom of your fraction by something that gives you a perfect power in the bottom that's going to allow you to get rid of the square root, right? So overall, the goal here for each of these that we'll just sort of keep in mind here. So the goal is that we want to multiply the top and bottom of each fraction by something that's going to allow you, so something that allows you to get rid of the radical in the denominator. In the denominator. Okay, so let's do an example. So the first example will be nice and easy, right? Because in order to get this square root of 3, in order to for that to be something nice, we would like this to be square root of 9, right? That would be nice because then we could just take that to equal 3. Well, now we can't just change it just because we want it to be that, we want it to be nice or whatever. So what we are going to do here is we're going to multiply the bottom by square root of 3. And then, of course, I don't want to change the problem, so I'm going to also multiply the top by square root of 3. Now, what that's going to do is in the top, you have 1 times square root of 3, which is just square root of 3. And then in the bottom, you have square root of 9, which, of course, is 3. Right? So now you have something where there's no radical in the denominator, and that's sort of considered the proper format that we want this to be in. Right? Now, of course, the reason why we're allowed to multiply by the square root of 3 over square root of 3 is because anything over itself is just 1. So if I multiply something by 1, I'm not changing it. So that's sort of why we're allowed to do this. All right, so let's look at another example. All right, now in the last one, what we did is we multiplied the top and the bottom by just what was in the bottom in this case. Now here you have 2 options, right? So again, you want this bottom to not have a square root. Now, the easiest way we could do that is we could make that 2, just leave it alone, and we could make that 5 a square root of 25, right? So that would be one thing that would allow us to write this without the radical. If you wanted to, you could also use 4 square root of 25, and the reason why that might be more advantageous to use is because in this case you would just multiply the top and the bottom by the term in the bottom again, but we don't want to do that. In this case, we'll just try and make the square root of 5 a perfect square. So to do that, I would need a square root of 5. And then, of course, we need to do the same thing to the top. Okay, so if we do that, the top is now y times square root of 5. And now to multiply these two things in the bottom, I have a 2 times, and if you want to think of a little 1 in front of here, you can, but we have a 2 times 1, so that's just still a 2. And then we get square root of 25. But again, square root of 25 is just 5. Oops. So that's a 2 times 5 in the bottom. And then the other one is still just y square root of 5. So all we need to do now is just multiply the bottom, and we'll get 2 times 5, which of course gives you a 10. And that's your final answer here. All right, so with square roots, it's not terribly too difficult in order to do that. Now, in this case, we have a cube root. All right, so we need to approach this a little bit differently. Now what we need to do is we need to get this bottom, we need this to be a perfect cube. Right, so I would need this to be something like cube root of b to the third, which we could then write as just b. Now the problem here is that if you multiply by just a cube root of b, that's not going to get us what we want, because that would only give you a cube root of b squared, right? So if we actually multiply by b squared, that's going to be what's going to get us what we want. So of course I need to do the same thing to the top. And now when we multiply through in the bottom, I have cube root of b times cube root of b squared. So that gives me the cube root of b to the third that we want. Right? Now in the top, nothing too interesting happens. We get a cube root. And then we have 32, which doesn't change. We have a to the fifth, what doesn't change. And then we're just tacking on the b squared. All right, so now we just have to simplify this as much as we can. So now the bottom is nice because that's going to give us the b that we want. And now in the top, we want to simplify this as much as we can. And we would do that using the same methods that we would do before, right? So we could think of this as cube root of 32, cube root of a to the fifth, and a cube root of b squared. Right, so if we look at the 32, let's come over here a little bit. So if we look at cube root of 32, we would like to write that as a product of two numbers where one is a perfect cube. So if you think about that, you'll find that 8 will do it. So we can write that as cube root of 8 times cube root of 4. So then cube root of 8 is 2, so we get a 2 times cube root of 4. Now, if we look at our cube root of a to the fifth, we can write that in our exponent form as 5 over 3. And again, 3 goes into 5 one time, so we'll get an a to the first times a to the 2 left over, so 2/3. And now we can think of that as an a times cube root of a squared. Right, now if you, of course, look at cube root of b squared, we can't do anything with that because our power on the inside is smaller than the index of our root. So that's just going to stay as is. Right, so now if we plug all these into the top of this thing here, so that goes here, that goes here, and then of course this didn't change. Right, but after all is said and done, of course, we get a 2 times an a. I'm just combining those two terms on the outside of the root. And then inside of my root, I get a cube root of a 4a squared b squared. And then, of course, I still have the b in the bottom from before. All right, so a little bit more work if you don't have a square root in general, but that's the idea here. All right, so hopefully that's not too bad. We'll just do a couple more examples of these. So for example, in this one we have a square root again, so not equal, but I want to multiply. So in this one we can multiply top and bottom by square root of 3y. And if we do that in the bottom, we're just going to get the 3y that we want, right? Because we'll get a square root of 9y squared. So if we take that square root, we get 3y. And then in the top, we get a 3x squared y. And actually, in this case, the only thing that we could simplify, we could have done it at the beginning, was the square root of x squared, which is just x. So then there you'll get a square root of 3. Let's put the x on the outside, and then square root of 3y. And then in the bottom, we have 3y. So that's our answer there. And we'll do one more of these, and then we'll talk about, well, what if that bottom has more than one term, right? So for example, in this one, again, we have a cube root, and we could think of this as, first of all, cube root of x to the 7th, y to the 10th over cube root of 4z, right? So for this bottom to be a perfect cube, we would want it to be a cube root of 8, so that that's a perfect cube, and a z to the 3rd. And then that would allow us to write it as a 2z. So in order to get there, I would need to multiply by a cube root of 2z squared. So I better do the same thing in the top. Okay, so in the bottom, we're going to get the cube root of 8z to the 3rd that we want. And in the top, I will have a cube root of 2x to the 7th, y to the 10th, and a z squared. So on the bottom, again, we do get the 2z that we want. And if, let's see, if I simplify this top, maybe off to the side a little bit just to save some space, we'll get a cube root of 2, which we can't do anything with. And then cube root of x to the 7th, we could write as x to the 7 over 3, which is just going to come out to be x squared, with 1 left over, so cube root of x. Just keep track of what we have. The next one, of course, cube root of y to the 10th, we could write as 10 over 3, and that will allow us to say that this is y to the 3rd with 1 left over. And then the z squared, since again 2 is smaller than 3, we can't do anything with that, so that will be a cube root of z squared. So now if we combine all of them into our top here, let's see, we're going to get, what do we have on the outside? So we have an x squared, y to the 3rd on the outside, and then on the inside of the root, we have a cube root of 2x, y, z squared. And there's our final answer. Okay, so those hopefully aren't too difficult. And now we need to talk about, well, what if your bottom, if you look at this example here, now it's maybe a little bit unclear at first because now you have 2 things being added in the bottom, right? So we need to do something else. And it turns out that what we need to do is we multiply by what's called the conjugate, right? So the conjugate is essentially whatever your expression is, except you're just now going to change the sign in front of the radical, right? So for example, in this problem here, we want to multiply by the conjugate of 3 plus 5, which would be change the sign in front of the radical, is now 3 minus square root of 5. So now we're going to multiply top and bottom by 3 minus square root of 5. Now, in the bottom, what you're doing is you're foiling these things, right? And again, you'll notice that you have sort of the difference in 2 squares thing going here, but let's just do it out just to prove it to ourselves. So we do 3 times 3, which is 9. 3 times minus square root of 5, which would be minus 3 square root of 5. And then a square root of 5 times 3, so plus 3 square root of 5. And then we'll get a minus square root of 5 times square root of 5 is square root of 25, which is just 5. Right? And of course, in the top, you're doing something similar, except we're just distributing. So we get a 6 minus 2 square root of 5. All right, but again, if you notice in the bottom, we have minus 3 square root of 5 plus 3 square root of 5, so those are going to cancel each other out. And then in the bottom, what we have left is 9 minus 5, so we'll end up with a 4 down there. And then we have 6 minus 2 square root of 5 up top. All right. Now, I guess the only thing that we have left to do at this point is just to simplify this a little bit more. So, for example, in the top, you could factor out a 2. You have 2 times 3 minus square root of 5. And then over 4. So, of course, 1 over 4 or 2 over 4 you could write as a 1/2. So this is just going to be a 3 minus square root of 5 all over 2. And that's our final answer there. So again, just a little bit more work, but nothing too terrible. And we'll do one more for fun, and then we'll wrap it up. All right, so in this one, this is actually an interesting example. So now again, our conjugate here, if I change the sign of this thing, will be an m plus square root of n. And then in the top, I also want to multiply by the same thing. Remember, you always want to use the conjugate of whatever's in the bottom, right? So in this case, you need to multiply by the conjugate of the bottom, which is this m plus square root of n. But anyway, in the bottom, you know, same thing is going to happen. We're going to get n times m, which is an m squared, right? And then the two middle terms will cancel out, and then we'll get a minus n when all is said and done, right? And then if we FOIL out the top, we got an m squared plus m square root of n, and we get a plus another m square root of n, and then plus square root of n times square root of n is just n. So it looks like if we combine our like terms, in the top we get an m squared plus 2m square root of n, and then plus n, and then all of this over an m squared minus n. Right? So of course we can't factor anything out here, so this will be the best that we can do, and that'll be our final answer for this one. All right, so that wraps up this lesson on dividing radical expressions. So I will see you in the next video.